Previously, we saw an example of a radio source analysis for the cluster Able South 1063, where we showed how morphological, mathematical morphology analysis allowed us to separate out compact from diffuse structures, and also a way to replace areas where we'd removed compact sources by in-painting, which allowed us to first of all get good flux densities for the cluster itself, but also show us how we can separate out the actual source signals from the point sources from the actual cluster imaging. So today we're actually going to look at a probably more complicated cluster, the famous bullet cluster, which is used for all sorts of things about whether or not we actually have dark matter versus the Mond, changes in gravitational effects, etc. Although we're just going to look at it from the viewpoint of, say, data processing. So without further ado, let's try starting up our standard example script. And the first thing we're going to do is determine what the starting flux density of this entire object is. And so here we see the bullet cluster itself. There's a large fairly diffuse area, although kind of a very sharp edge on this side. And there are also some very bright, relatively bright, compact features here, which probably indicate some kind of shock front structure. And we want to try and separate out the flux densities of this object from this area, etc., etc. We can also see there's a number of probably background sources in the cluster, which we would like to remove through the in-painting analysis we did, for example, in the Able South 1063 one. But there are also some kind of rather compact objects around here, which, as we see, are somewhat harder to, which require a little bit more processing. Anyway, just to start up here, we're going to determine the flux density of this thing at about the 3.5 sigma level. So we're just going to go and click on this guy here and see what the flux density of that is. There are a few other sort of sources nearby which we're not going to include in this sort of some of the diffuse area emission, although they might well be associated with it. Anyway, we'll go ahead and click on this. You get a flux density. And we can find that when you do that, the starting flux density is actually about 286 millijanskis. Now, the next thing we want to go on to do is then try and separate out, using the techniques we developed for Able South 1063, which we, again, we're using double erosion. So we're going to try and remove some of it. Actually, like we did in Able South 1063, we first want to add a few components back into the diffuse image, which we think are just sort of slices off the top of the morphological data mask, like happened in 3C236, for example, where we had a few leftover point sources which you had to add some features back into the actual diffuse image. In this case, we're going to add in back this kind of ridge-like structure here, or peak here, and the structure over there. We'll let other objects get in-painted, etc. Anyway, so let's start here by clicking on the things we want to add back in. We want to add this thing, kind of a shock front, and we want to add this guy back in. This is just a peak diffuse structure like happened in 3C236, which you want to add back in. So we'll go ahead and do that. Now, what Keegan Trevahan noticed originally was that when we go to this situation, we got all this stuff around here floating. If we want to, let's see if we got Keegan. If you might remind yourself, when we look back at the original image here, that this feature here is not really something that we can inpaint directly, because let's go back and look at our original image. Blah, blah, blah. Here, where are we? Let's see. Okay, let's cut that back. When Keegan did original inpainting, he found that this sort of kind of fish-like structure here was had kind of a separation of signal, where we sort of, on this side we kind of get reasonably in painting, but on this side it's way weaker. And that, of course, is because of Navier-Stokes in painting, which we're using in the case of Able South 1063. Works on the assumption that the signal is flowing in from a surrounding area to and painting an area which is fully surrounded by brighter emission. But unfortunately, this guy here, while it has some connection to these features over here, is actually on this side has absolutely nothing except sort of a few kind of background sources. Or anyway, there's nothing here flowing in from the outside, so we get this bifurcated structure, which is really not representative of any kind of physical reality. So what we do, we can now separate this image, which does not have any bright feature in it, and move it back into move its structure back into the compact features image, where we'll be able to pick it up and get proper flux densities for it when we determine the flux densities of background sources which we're interested in the final step of the processing. So this thing calls a function called calling a function called generate separate masks. I'm not sure that's a particular good name for it, but it is what it is at the moment. So we can actually, let's open that up. So we want to generate the mask for this guy and this guy. So let's generate them, and that'll be moved. This operation with the separate mask will actually move these two things into our point source image feature. So we're going to demonstrate that. Now, once we've done that, our fish-like structure has actually been removed from the diffuse structure. So we can actually go ahead and figure out what the diffuse structure flux density is. And we can just process that. And let's just see what that came out to. No, we don't want to save it. Cancel. What is our flux density here? So our flux density at the whole thing is about 93 millijanskis. And we can actually say, oh, okay, is there something here which we can, let's see, okay, so we can actually try and convolve this thing. And let's see, convolve this, let's say, just again convolve this guy. We actually have convolved that, I can see that. So one of the things we notice here is because we did convolution, this probably head-tail galaxy here has now incorporated into the diffuse image. So we're going to find that our convolved image structure is slightly larger than the previous structure. So let's see what we got there. So the bullet structure convolves source parameters. Let's see, where's our flux density? It's gone up from about 93 to 102 when we did convolution. That's because one of these sources actually kind of got incorporated back into the image. Anyway, we now can go ahead and look at the our final point source feature, which has all these point sources. We're of course now only just because we moved this feature back into the point sources. We'll just say, okay, we want this flux density for this object. For this object, we have two bright sources inside the image. So we want to get this one, and this was an object we partly did smoothing or in painting where the in painting was reasonably well, so we still need to get a flux density for this guy. And so we got 5 separate objects. And when we go through that, where's our flux density? Sum the flux density. Anyway, we can add up our flux densities from the source parameters. And that's actually about 180 or so millijanskis. And so the 180 millijanskis from the point sources plus the flux density from the diffuse emission come to about 260, so I don't think there's any great extra emission that appears. Unlike in the case of the Able South 1063 source, there isn't a lot of strong emission which appears out due to convolution. So that's a sort of a brief example of how we can use both the mask separation, etc., to separate out, get reasonable flux densities for both the diffuse image and the sum of point sources which we're interested in. So I hope this information was useful to you, and that's all for this